Are you worried about meeting the time and budget commitments that you and your team have made on projects, or are simply under pressure to do more projects faster with the same resources at the same or lower cost? Well, if you face one of these two challenges, or maybe both, I think you might find the next few minutes really, really interesting. Over the past 5 years or so, we've been working on a breakthrough technology, a technology that combines the best of simulation modeling with AI, with optimization engines, and then also a database of best practices to create a new decision support software app called the Project Portfolio Digital Twin. It essentially helps you to build instantly a complete digital twin of your project portfolio environment. Now, why do you need something like this? Well, there are four really simple but very important questions that almost all project managers face that the current technologies simply cannot answer reliably. The first one is, will your projects actually achieve the time and budget commitments in real life conditions? What do we mean by real life conditions? Well, you estimated that a task take 10 days, but it can in reality take 6 or 7 days, but it could also take 15 or 20 days. You don't know what will happen in reality. What if you could run a simulation that shows you all the possible outcomes based on the expected level of variability? Secondly, how do you know whether you could do better? Just by changing the way that you plan and execute these projects. Well, what if you had the capability to try out different planning and execution strategies and tactics, best practices like Agile, Kanban, and theory of constraints, critical project management? The third question is, how much better could you do if you had the ability to change the resources? Maybe add bottleneck resources and remove the excess non-bottleneck resources. How much better could you do operationally or financially? And last question is, what will be the impact of unplanned events? Things like the scope of your project suddenly changing, or maybe there's supply chain issues that is going to delay your project. How do you know how much it will impact your operational and financial performance? And what would be the best way of mitigating that? Well, that's exactly the type of questions that we designed our project portfolio digital twin from. We designed it from the ground up, and over the past few years, we've been stress testing it with some Fortune 500 companies that, at least for us, gave us the level of complexity of projects that could really stress test our platform. What I want to do in this short demo is to just show you quickly how it works. The first step is essentially selecting the mode at which you want to run this digital twin simulation. You can run it for a single scenario, single run, or to do some sensitivity analysis on one or more of the parameters, or to do a scenario comparison. I'm going to show it in demo mode, which is a scenario comparison. And you'll see at the top that there's essentially just 5 simple steps. It normally takes about an hour or two to learn how these work. Step one is you upload the data, which will be a simple export out of your project management system that contains the full work breakdown structure of your project portfolio, together with resource availability, costings, when revenues are recognized, when costs are incurred, if costs are variable or fixed. And even you can add whether there's penalties for late deliveries or bonuses for early completions. Step two is going to be where the platform is going to show you the data that you've uploaded, show it you in really simple terms, but can help you to see what are the type of questions that might be interesting to ask or the type of hypothesis that you want to test. Step three is going to be where you're setting up the scenarios. Step four is actually running the model, and step five is just reviewing the results and deciding what to do. So we're going to load a default scenario here. We will provide you with a template that you simply copy and paste your data into. And you can see literally within a few seconds, it's now built a complete digital twin of this environment. We can see on the project portfolio, we've uploaded data for 10 projects. They are all starting on the 4th of January and planned to be completed on the 4th of May. So about 5 months, it's about 120 days of work. We can see on the Gantt chart here, this is essentially, they are all being launched all at the same time, all 10 projects. These are condos, building small condo units. We can see from the resource planning that we've got all these resources. There's essentially 5 of each, so 5 teams, and each team is working on 2 projects at a time. We can quickly see from the resource utilization that there's no resource that is overloaded all the time. The most loaded resources are walling contractors at about 60%, but there are times where they are loaded up to 360%. But we're not sure about whether those will just sort of even out based on the randomness. And we can also see from our financial side that we are planning to complete these projects with a profit of about $300,000. We want to use this simulation to simulate this project portfolio to see, are we going to make the time and budget commitments, and are we actually going to achieve the budget that we've planned for. So let's go to step 3, which is setting up the various scenarios. I've got these pre-configured. So scenario 1 is basically our baseline. It's executing the projects as they are. And part of as they are is the rule that they have for launching projects is that they launch 2 projects per team. They've got 5 teams. That's why you see 10 projects in process. The logic, very simple. 2 projects per team. They are switching between these 2 projects on a daily basis. If there's a delay on one, they can keep on working on the other one. Scenario 2 is, what if we stop them from switching? They must do one before they can continue with the other. Scenario 3 is if we use critical chain project management to reschedule that portfolio of projects and not launch all 10 of them, but kind of stagger them based on our bottleneck resource. We only have 5 of those walling contractors, so maybe we should release 5 and then sometime later another 5. Our simulation model is going to find the optimum schedule. It will look at all the possible options that there are and come back with the most optimum schedule for you to be able to do this project in the fastest possible way with the lowest cost. And then in scenario 4, we want to see what happens is, on top of using critical chain project management to reschedule, what if we also allowed extra resources to be used when they are available? So maybe our plan specifies that we only use 1 walling contract at a time, but what happens if a project started at that time we had 2 available? Why don't we grab both, get that project done as quickly as possible, and then move on to the next project? So we're ready to start, and we are going to run this simulation both in perfect world, which essentially means that whatever task durations we planned, what if it always happens? So if we plan 10 days, that it always happens in 10 days. So the only reason why projects would be late in such a perfect world environment would be if capacity constraints weren't fully considered during the planning period. And we've already noticed that there are cases where some of the resources are loaded more than 100% for a specific period of time, but we're not sure whether that will not just balance out. In real world, we add randomness to that task duration. So a 10-day task could take 5 or 6 days, but it could also take 15 or 20 days. So we'll run scenario 1 just to see what's going to happen. This is a fever chart, so each of those traces is the progress of the project. Red means it's in trouble. When it goes into green, when it goes into gray, it means it's late already. And you can see what's happened. We were planning to finish these projects in 120 days. They ended up taking 227 days on average, and the total portfolio took 271 days. If we look at the Gantt chart, we can zoom into a little bit more detail there. We can see that gray part was what our original plan was, and you can see most of the projects took almost double the amount of time, depending on the level of randomness that they experienced. And that stopping and starting, where you see the green totally interrupted with red and blacks, basically means that the projects weren't flowing. Green means that they were flowing. So you can see a lot of multitasking, switching between projects, and that's probably what caused most of the delays. Also in the simulation, when you click on one of these bars, it will give you a complete analysis of that project down to what was causing most of the delays. Was it pure task variability? Was it waiting in backlog? Was it waiting for resource to start or complete? Was it waiting for full kit? Was it because of multitasking, overtime, Parkinson's, etc.? And we can zoom into a lot of detail. We can take this down to the task level. And again, if you click on one of those tasks, it gives you this full details. So we know that we planned this to be 120 days. It took 271 days for the portfolio to be completed. And you can expect that probably we're not going to make money. We can quickly go to our financial dashboard and let me compare it with a target. Our target was $312,000 profit. You can see because of the massive delays, our cost have gone from $720,000 to $1.6 million because of those delays. Most of these people are permanent, so we had to keep them on. And the second thing is we paid some penalties for late delivery, so that was not great. Now, the question for those other three questions is, could we do better just by changing the rules? And that's essentially what we're going to do with scenarios 2, 3, and 4, just changing the rules. Scenario 2, no multitasking or Parkinson's. Scenario 3, replanning based on our capacity constraint. And scenario 4, replanning, but also allowing some additional resources to be used. We'll switch to this portfolio mode because it's pretty cool to see the animation running like that. Let's see what's going to happen. So green means it's going okay. As it's starting to go up, it means that the project is consuming buffer faster than what it's making progress. So you can see in scenario 2, in real world, many of the projects were still late, but we went from an average project duration of 227 days with multitasking down to 128 days. That is a big, big reduction. Total portfolio used to take 271, now 160. When we use critical chain, we got some additional reductions of about 5 days for the total portfolio, but the real benefit came from allowing some additional resources. So by controlling the release, we're going to make some resources available. We allow those resources to be utilized on the highest priority projects, and now most projects are early or on time. Only this one was late, and it was only late by 5 days essentially. So much, much better portfolio performance. What about the financials? Could we actually make money? Remember, we lost like 870,000. Awful. Well, just stopping multitasking, we got above break even. Using critical chain, we got to 141,000 profit. And using critical chain plus allowing extra resources got us to 245,000 profit, very close to what the original plan was. And that's the power of the simulation. Is the only time you would have known this would have been in execution after a couple of months where you started seeing that the projects are being delayed, that you're already over budget, and it looked like there was no hope to catch up. Now we can do all of that testing in a virtual mode. And there's a lot of analysis in here, so we can go to a specific project, like in this one. We can select a specific project, let's say project 8. The green portion is the actual work time. The rest is all delays. And it will show us what caused most of the delays was waiting for resource to complete the tasks. And by far the biggest one was our designers, which is interesting because we thought that the most loaded resource is a walling contractor. Then it's a walling contractor, and then it's a roof contractor. So you can get this analysis by project, but also for the whole portfolio to see where the biggest delays are, what's the biggest causes. You can also get complete information around bottleneck analysis, your constraint analysis, find out what the utilization is of the various resources, see where queues are building up, look at the resource Gantt chart to see how the projects were being executed. Like I mentioned, all green means they were flowing. Green, yellow means stopping and starting. That's never good. And then the variability analysis, seeing where the projects are late versus early. So that's the power of this simulation tool. It really helps to gain confidence about whether you are going to be able to deliver your projects on time and on budget, allowing you to do the testing essentially in this virtual mode. And secondly, also helping you to check if it's possible to do more projects faster with the same or even less resources, again, all in the virtual mode. This type of analysis is simply not possible with the existing project management software or optimization engines. They cannot do full dynamic simulations that what we are doing here. If you think that this could be useful, it's really easy to try it out. All that you need is essentially an export from your existing project management system. With your full work breakdown structure, you can use this tool to just model a single project or a portfolio of 100 projects that span the next 10 years. It doesn't really matter. It depends on the export of data. And on top of that data, you just add the expected randomness. You can also add any unplanned events. Click the play button and see what will happen. If you are interested in this, you're welcome to contact us. We'll include a link in the comments below where you can reach out to us, and we can also share with you a copy of this where you can try it out on your